This talk is how not to be a Git, tips and tricks for a good workflow. And I'm Adam Jimerson. I'm a software engineer for Code Journeyman out of Chattanooga. I'm also the organizer of the Google Developer Group out in Chattanooga. So I do a lot of things with Google. There's my email address if you want to contact me, or you can just hit me up on Google Plus at +Adam Jimerson. So, what is a Git? Well, according to Wikipedia, there's two main definitions of Git. First is a distributed revision control system and source management with an emphasis on speed, integration, and support for distributed nonlinear workflows. Or a Git is mild profanity from British English for silly, incompetent, stupid, annoying, senile, elderly, or childish person. For this talk, we're talking about the first definition. So if you're not familiar with Git, that's okay. There's a lot of good materials out there to help you learn. GitHub and Code School actually has an interactive tutorial that you can go through. It's a virtual shell type environment. They walk you through the steps from git commit or git init to adding files, committing, working with remotes, everything you need to know. Bitbucket also has a few good tutorials. And then there's also the Pro Git book, which you can order, or there's an online version that's constantly updating. So that one's probably the better source between the two. So before we get too much farther, let's start with the tips. So at some point in time, you're going to need to ignore files from Git. Typically, that's done through a git ignore file within the repository. Git also has the ability to do global. And so this will exist somewhere else, like your home directory. And this allows you to have files that you typically ignore in every repository there, keeping the one within the repo truly repo specific. So files made by your text editor or IDE, things for user or environment specific configurations can go into the global versus that. There's another way you can do it too. So within the .git info directory, there's a file called exclude. You can add file names into there, and it works as if you put it into the ignore file without it actually being there. The main use case for that is if you have files that you don't want other people to know that you're ignoring, but you truly are ignoring. So say you have a file of names of developers that break the build constantly. You probably don't want people to know you have that file. And so a good thing to always keep in mind is always name your remotes. So typically people would just type git push or git pull. That's not the best route to do. You always want to name your remote. So git push origin or git push and then your build server or whatever. And by doing that, you get in the habit of always doing it. So when you are working with multiple remotes, you're just in that habit. It just all works. And but a lot of arguments is that's a lot of typing to do, or I only ever work with one remote. Just get in the habit of doing it, and you find that it's not actually that hard or that much extra. And then there's some other workarounds too. So you can set up aliases. So like in mine, that may be hard to see, but I have an alias for a command ggpull that actually runs git pull origin, and then it looks at the current branch that I'm in and will pull the remote version of that branch. Or ggpush, which does the same for a push operation. Another thing that Git has that people may or may not know is Git has the ability to autocorrect. So at some point in time, you've probably done something similar. You fat finger or typo something, and you get this message that it doesn't understand the command. In this case, a plush. Well, while Git doesn't have a plush command, it has a push, but it just telling you that did you mean push, and then exiting is probably not useful. So you can set the help.autocorrect to be true, and instead what happens is when you do that, it'll look up and it'll tell you you've mistyped. It'll give you a suggestion, and if there's only one command that actually matches what you typed, it'll just go ahead and run it for you. And if there's multiple, then it'll just exit as normal, giving you the list of commands, because it doesn't know what you mean at that point. Another useful thing is telling Git to remove white spaces from commits. And a lot of people don't like having trailing white spaces in code, and some people go to the point to where they don't want those in commit messages either. Well, you can set the filter within your Git config. And so what that does is when you save the commit message, Git will automatically go through and clean up trailing white spaces for you. Another thing is the default Git log output, not that helpful. Well, there's a couple things you can do. There's, I have that insane thing aliased to GL, and I'll show you to see what that does. May be a bit hard to see, but we have the commit structure, including any branches there, the SHA out to 6 places, then the summary message for the commit, the time that, or how long ago it was done, and the author. It's all single lined, and it'd be a lot easier to see than the default, which is just display everything in a flat file, basically. And another option that's actually even shorter is running the graph and telling it to color. And you get, these are still a bit small, but this does almost the same. Instead, it doesn't do the commit structure like the last one does, but it has the full SHA for the commit, the author, the date the commit was done, and the full message. So another thing that people do is, say you do a lot of work for your personal stuff and a lot of work for your work business or for multiple clients, and you have different email addresses. Well, the git config file is really only set up to do one email address at a time. So what are your options? Well, we can set up, so we can edit the git config file for each repository manually, changing the email address every time, but that's just a lot of work. Or we can create a git command that will set the email address for you within the local config for that repository, making it repo specific as well. And to do that, it's just a matter of setting up a git alias inside the git config, and we call config user.email, giving it the email address we want. And then inside any repository that we want to have that name or that email address, we just say git and our aliased command, and it will handle everything for you. And then also sometimes you may not be on the fastest internet connection, and trying to establish remote connections may take a while. Well, while this isn't necessarily a Git trick, more SSH, but it still affects the Git connection. We can set up SSH to allow connection sharing, and so what that does is it will use the same connections multiple times for multiple operations. And it's just a matter of setting 3 commands in the SSH config file. The first one tells SSH to keep the connections open, or it tells it to reuse existing connections if one exists, otherwise create a new one. The second one, the control path, is actually setting a socket file to where the information for these are kept. So the %r gets replaced with the username, the %h is the host, and then the %p is the port. And then the last one, the control persist, if it sees that file, it'll look into that file, grab the information for the connection, and then just reuse that instead of reconnecting to the remote server. And so now we'll move on to actually workflow style things rather than tips. So first of all, branching. And so two things you need to know is how to work with branches and why you should work with branches. Well, what's a branch anyways? A branch is a special fork of the code base allowing you to make changes to your code, but it doesn't affect any other branch or anything else. It's all local. And that's just a very simple explanation of the branch. So to list all branches you have, you just run get branch, and it'll spit it out. It's one line per branch, and it'll put an asterisk and highlight the one you're currently on. So in this case, I have a develop branch and a master branch that this was sitting on. And creating branches is as easy as just running get branch and then giving it a name. So say we're working with a specific branching model called get flow, where you have a master, a develop, and then you do feature branches. Well, we want to create a feature branch. So we'll say get branch feature slash, and then whatever feature you're doing, or a ID within your ticketing system for a bug you're working on. That way you can identify what you were accomplishing within that branch if you ever have to switch context. So to switch branches, it's just get checkout and then that branch name. And what that does is it takes the information about the changes between the two, saves them, and then switches over to that branch. So you don't actually lose any work doing it either. Another way is you can also create and switch over to a branch in one go by passing the checkout, the -b, or the branch argument. And then that does both for you. So, working with branches. So I already went over separate code changes when adding feature or making changes. They go in different branches. By doing this, it allows for easier context switching, especially if you use identifiable branch names, so you know what you were working on when you're switching. So another thing you can do is squishing commits. So say you have two commits that really should have been one. You can merge them in. There's two ways of doing it. There's one called recursive merging, and then there's one called rebasing. So before we go into this, though, a little word of warning. Don't do the following if you've done a push between the commits, because that will cause the remote server to actually reject any changes from that point on, because you changed the history within the repository. And so because of the history differences, it's not going to know what to do. And things are guaranteed to blow up on you if you try it. So the first way to do it is by running git commit, but passing it the amend argument. And what that does is it'll take the files that you have, your commit, and the new files that you're adding, and it'll recursively merge it into that previous commit, making it one. And so this may be a bit small to see, but I have a commit where I have added files, and I meant to add another one. So to do it, I say git add, and then the file I missed, and then git commit amend, and it just rolls it into the previous commit, and no one knows that you've missed that file. The history, when you look at the log, you'll only ever see that first commit message. And there's a bit of proof. So that first entry there in the git log is actually two separate commits. where I was adding files. Well, that's good and all, but eventually those are going to have to get merged in. So there's two ways to do it. You can do by a rebase or a merge command. I think it missed a slide. All right. So I don't know what happened to that slide. There was one before this, but the way to merge branches recursively is just by switching to the branch you want to merge into, and then running git merge, and then the branch name you want to merge in, and that does a recursive merge. Or you can rebase, which rebase allows you to do it interactively. It'll give you a list of your latest commits up to the last push, and then you can sit there and you'll have options. So you can say you want to keep it as is, or you want to rewrite something in it, or you want to squash them. And I'll show that one here in a minute. Word of warning about rebase, though. Rebasing alters the history of the repository because it actually goes in, steps back to the point before the changes you're making, and then replays it, also putting in all the changes. So it is considered to be destroying. So if you mix merges and rebases together, you can cause an issue upstream because of those changes. And then this is a visual representation of what happens. So each circle represents a commit. The blues are ones that are not changing. The reds are the ones that will be rewritten. And then the arrow shows the path. So we're wanting to merge in that third red commit into into the second. So what it does is it steps to the commit before that, and they'll run through and merge them all. So instead of having 5 commits, we'll just have 4. And then here's a screenshot of the interactive. So within here, you have the list commits, and you can say pick, which means leave as is. You can say squash, which that merges into the one before that commit. Or you can tell it you want to rewrite, which allows you to rewrite the actual commit message for that. Or you can alter the commit entirely. Well, here's that merging by the git merge. So as I said, it's just checking out to the branch you want to merge into, and then just saying git merge, the branch to merge. And this is a screenshot of it working. It shows you the files that are being altered and the number of changes to the files. Git merge works in 2 ways. There's a mode called fast forward, which is technically a rebase, and then there's the recursive merge. And the merge command is smart enough to figure out which one is the safest route to go depending on the differences between the 2 branches. And so if you wanted to rebase the branch, it's similar. So you'd say git checkout, and then your branch you're merging into, and you just tell git to rebase it, and it will only fast forward at that point. And the output's actually quite different. So instead of giving you the list of files, it just tells you it's first going to rewind the head, replaying the changes, and then fast forwarding to the last commit that exists now. So it's less verbose in the actual output it gives you. So why would you pick one or the other? Well, there's two camps about this. There's the always merge camp, because those people, that side of thought is you should always keep the history intact. Don't ever change it. And then there's the always rebase camp, and they want you to do that, because the difference is merging actually keeps the commit structure. So as you're branching, the actual log looks like old bridge. So you have the structures. Well, rebase will actually flatten it, so it's just a linear tree. And so it just depends on that. Now, you're going to want to pick one and stick with one as a team. Don't mix the two. Huh?
Question on that?
Yeah.
Wait till the end.
Go ahead.
Okay. Something that our team does is that if we're working on the, or maybe it's just me, I don't know. If we're working in the same branch and with someone else and collaborating with someone in the same branch, then we'll just always rebase because we're on the same branch, right? There's never going to be any problems with rebasing. However, if we are bringing in changes, like let's say we're on a feature branch, we're using Git flow or something, we're on a feature branch, we want to bring in latest develop, we'll always merge that in instead of rebasing. Or if we want to get changes from some other branch, we'll always merge that in. So same branch rebases, other branches merge. I don't know, thoughts on that?
That is a valid way to do it. I've actually seen that cause trouble once or twice, because there was a change in one of the things you were merging in from a remote branch that depended on something there being in the history that you've rebased, and it's gone, and so Git just gets confused.
Okay.
So that's only if two people are working on something similar. So it's an edge case, and shouldn't happen a lot, but it can. So it's something to look out for. And so another thing you can do with Git is finding bugs and who introduced them. A little known feature of Git is a command called bisect. And I'll talk about that here in a minute. And then there's also a git blame command. And so with the bisect, what you do is you tell it a starting point and an ending point. It will work out where in the middle of that commit tree and put you there, so you can test for a bug that may have existed. And then it'll ask you if this is good or if this is bad. And so depending on what you tell it determines if it will move you back or forward. And so the point of this is you're testing, finding out the commit that actually introduced the issue, so then you can fix it there. And so instead of doing it manually, Git can actually do that for you. And then once you're done, you just reset. It'll put you back at the latest. You know where the issue was introduced. So now you have a diff. You know exactly what caused it. And so if you want to know who did it, you can do a git blame. And so you run git blame on a file or a commit SHA, or if you leave that blank, it assumes head. It'll show you the file with the authors of every line, the latest author for every line, and the commit that line was last altered. So you can find the person who did it, or introduced the issue or the change, and get basically figure out why they did that. And that's all I have. So.